Welcome to solverfy.
This is the answer to Chapter 19, problem number 69 from the Smith Organic Chemistry textbook. And this problem says glutamic acid is a naturally occurring alpha amino acid that contains a carboxy group in its R group side chain. And they've drawn glutamic acid in the textbook here in a neutral form with no charged atoms. And of course, we know that that doesn't actually exist at any pH. At neutral pH, it's the Zwitter ion. So this question is in three parts. So part A says, what form of glutamic acid exists at pH 1? So at pH 1, that's a very acidic environment. And so what we have is at pH 1, our amine will be protonated. And both of our carboxylic acids will have their protons on them still as well. So COOH. And I'm going to keep drawing this the way that this problem draws it in the book. So this is CH2CH2 COOH. So CH2. It's a weird way of drawing it, but this is how the book does it. So there we go. So this is at pH 1. Both of the carboxylic acids are protonated, and the amine is protonated as well. So then for part B, we are asked, what are we asked? Okay. If the pH is gradually increased, what form of glutamic acid exists after one equivalent of base is added, after two equivalents, after three equivalents? So as base is added, protons are going to be removed one equivalent at a time, starting with the most acidic, and then the next most acidic, and then the least acidic. So going from this first molecule that we've drawn here for part A, rather than redraw. So this is going to be one equivalent of base is going to remove the most acidic proton, which is the proton, so not this carboxylic acid, but this carboxylic acid. So this one is going to be deprotonated first. Okay. And so if we then add a second equivalent of base, so a second equivalent of base, we will remove the next most acidic. So this guy will stay deprotonated, obviously. And the side chain carboxylic acid will now be deprotonated. So CH2CH2 COOH. Okay. And then from there, if we were to add one more equivalent, so a third equivalent of base, now we're going to finally deprotonate. Oh my, I said one thing and drew another. I do apologize for that. So that's not right. So that will be I said it was going to be deprotonated, and then I drew it still protonated. So that's not great. So there we go. That'll be deprotonated. And so the third equivalent is going to deprotonate the amine. So there we go. The amine will be deprotonated. So doubly negatively charged after that third equivalent of base. Okay, and that's part B. So I wanted to try avoiding going to a second page, but rather than cram stuff in, I'll just do this. So for C, we're asked to come up with a structure for monosodium glutamate, which is MSG. I don't think it's in food as much anymore. It used to be in food quite a bit. It's like not very good for you, so they stopped putting it in lots of things, which is good. So monosodium glutamate is going to be the sodium salt. And it's going to look like this. So we're going to have this molecule in its doubly deprotonated form, but there will be a net charge of 0 because the positive charge on the amine and the negative charge on that carboxylic acid are going to cancel one another out. And then we will have our negative charge on this carboxylic acid. And as the name implies, monosodium, we will have a sodium ion to counterbalance it. And so this is monosodium glutamate, or MSG. All right. And so that's part C. Once again, here are parts A and B. And that's the answer to chapter 19, problem number 69.